All right, so yesterday we finished 3.1. Today we're going to start 3.2. But there's a good amount of stuff in 3.2, so we'll split it into 2 days. So we'll do half today, half tomorrow. Okay, just a reminder that, again, tonight, normal homework assignment. Tomorrow night, take-home test. That means no test in class on Friday. So Friday, we're just going to do a normal lesson. Okay, that's the plan on Friday. All right, so first I just want to look at the title for a second. Okay, because we've already talked about functions. Okay, we've learned that something is a function if it passes the vertical line test. You can also tell if it's a function if you look at the first numbers in a coordinate and you don't have any repeats. Now we're going to talk about a special kind of function called linear. If you look at the word linear, does anybody recognize another word in that word? Yeah? Line. Okay. So when we're talking about something that is linear, we're talking about something that is a straight line. It could be a horizontal line, could be a line on the diagonal, but we're talking about something that's a straight line, okay? Not a curve. So there's a certain way that we usually write the equation of a line. You might have done it last year. And on your guided notes, it starts out with y equals. And does anybody know the formula for how you write the equation of a line? It has 3 letters. Yeah? Right. It's y equals mx plus b. Okay, so on your guided notes, on the blank line, fill in y equals mx plus b. And now the m and the b means something. Can anybody tell me what the m is for? Sean? Yeah, that's the slope. So m is what we call the slope, and that basically tells you how steep your line is. And how about the b? Anyone know that? Y-intercept. What does that mean? Y-intercept. That sounds like a fancy term. What's the y-intercept? So where the x and y axes meet, that's the origin. If I think that's what you meant. That's where the x and y axes meet. That's the origin. Sean?
It's where the line passes through the y-axis.
Right. Intercept means where it passes through or where it crosses the y-axis. So if you had a graph like this, and you had a line just like that, we would say that has a y-intercept of 3 because it crosses through the y-axis at the number 3. This is not the only way to write the equation of a line, but it's definitely the most common way that we use. Okay, y equals mx plus b. And if you use a calculator like this, I can type something in, like 3x plus 5, and it will automatically graph that line for me. And since I put in a plus 5, it should cross the y-axis at exactly 5 units up. I don't know if you can see it. 1, 2, 3, 4, 5. So this will graph lines for me automatically. But I have to type them in on this calculator the way I just showed you. Y equals mx plus b. Okay, so this graph is a straight line. So on your guided notes, you've got a hyphen right below the 2 arrows that come down. Go ahead and put this graph is a straight line. So we can have lots of graphs that are straight lines that are functions. If you had a line like that, it's a function. If you had a line like that, that's a function. But there's one type of line that you could draw that would not be a function. What kind of line do you think, if you drew it, it's not a function? Yeah?
Intercepting one?
What do you mean?
Two lines across.
Okay, so we're just looking at a single line. There's one type of single line you could draw, and then this line is not a function. Yeah?
Isn't it like going up and down?
Yes, a vertical line. Because we talked yesterday about vertical lines. If something is vertical, that's not a function. Okay? So a linear function is any type of line that is not up and down. Cannot be vertical. Think about what would happen if it was vertical. Draw a vertical line. Now, let's see if that's a function using the vertical line test. There's my line. I'm going to drag through it. And as I drag it through my graph, does it ever hit the graph more than once? What do you think, Dorian?
Yeah.
Yeah, how many times does this line that I'm dragging through hit that vertical line that I drew?
Twice.
More than that.
Infinitely.
Infinitely many. It hits it everywhere. Right? It's not like it just hits it once or twice. If I put it right there, it hits it everywhere that it possibly could. So this graph really fails the vertical line test. So vertical lines are definitely not functions. And that's one reason why I can't draw them on this calculator. This calculator can only draw things that are functions. And vertical lines are not. So I can't draw them. But I can do horizontal, and I can do ones on diagonals. Those are fine. So one thing that's special about lines is they have constant slopes. Okay. What a constant slope means is that if you were to stand right here, or stand here, or here, or here, or there, it doesn't matter where you stand on that line, it would feel like the same steepness everywhere. The steepness never changes. It's the same the whole time. Now, if you compare that to something that's like this, if you were standing right here, it would basically feel like it's flat. Okay? It's the bottom. If you were standing here, you would feel like you're almost going to fall downhill, right? Because it's very steep, and you'd feel like you're going to fall down to the right. Now, if you were standing over here, it would still feel like it's very steep again, but it wouldn't feel like you're going to fall to the right. You'd feel like you're going to fall down to the left. If you dropped like a ball there, it would roll to the right. This is a curve, and it has a different steepness depending on where you would be standing. A line doesn't. It's the same steepness everywhere. And that's what we're going to study lines. So the next bullet you guys have says a nonlinear function does not have a constant slope. That shape that I just showed you, that's a function. How do we know it's a function? Well, try the vertical line test on it. Take a vertical line, drag it through, and see if it ever touches it in more than one spot at a time. And the answer is no. Never touches it more than once. So we would say that that's a function, but it's not straight. So we would say this is a function that is not linear. Non-linear. So there's really two different words we're looking at here. Something that's a function versus not a function. And then something that's linear versus not linear. Function versus not a function, you use the vertical line test to figure out. Linear versus not linear, you look at the picture and say, is it straight? If it's straight, it's linear. If it curves, it's not. So how about a shape like this? is that a function? What do you think, Emily? How come? Because, sorry, can you say that again? Right, if you drag a vertical line through it, it never hits it more than once. So, I agree, it definitely is a function. But, is it linear? What do you think, Aiden? So what does it mean if it's linear? What did we say linear means? What word is in linear if you write it out? Line. Does that graph look like a straight line? No, it's not a straight line, it's a curve. So we would say that this is a function, but it is not linear. It's a non-linear function. All right, let's look at some other examples. So example 1, you don't have this drawn, so you'll have to just, doesn't have to be drawn perfect, just basically some type of U shape. And the question is asking, not if it's a function or not, it's asking if it's linear or non-linear. That's what they want to know. So, Mia, what do you think about this one? Is this linear or non-linear? How come? It's not a line. This is a curve. So this is non-linear. And you'll have some like that on the test. I might set it up as like a drop-down. We'll click the box, and then you choose linear or non-linear. But that would be it. So that is non-linear. Right, let's try B. Okay, what do we think about that one? Linear or non-linear? Tirza? That's linear. It's linear because it's a line. Remember, the only line we don't want is a vertical line. If it's vertical, that's not a function. All right, why don't you guys try C and D? The question is, are they linear or non-linear? All right, so let's take a look at C and D. Okay, what do we think about C? Is that linear or non-linear? Yeah? Tirza?
Linear.
That's linear. So that's linear. And how about D? Joe?
Non-linear.
That's non-linear. We studied graphs that look like D. I can type in a graph like that and my calculator will do it. Let me type that in. I think I can actually do that exact one. So that's 1, well, I can roughly get it. So it's a +2 and a -1. So this is going to look pretty close. Not exact. It's a little wider than it should be. But that graph is not linear. Okay, to be linear, it has to look like y equals mx plus b. And if you looked at, oops, let me see if I can grab that with the cursor not blinking. I'm trying to get it at just the right time. Maybe. Ha. I can't get it. So there's a black box that keeps popping up over the first thing that I'm trying to show. So maybe if I do that. Huh. Oh. So there is a bar right here. Does anybody remember what those bars in red are called? Yeah?
Absolute value.
Absolute value. D is the graph of what an absolute value looks like. Absolute values are not linear. They have a V shape. Okay. So we haven't really studied the graph of absolute value. We've studied absolute value a little bit, but the point is they're not linear. All right, so let's, I think that's it for the front. Let's take a look at the back. So I've shown you guys how to identify if something is linear or not by looking at a picture. Well, what if you don't have a picture? What if you had a table like that? Well, you could, if you had a big enough piece of graph paper, you could graph all of these points and see, do they look like they're in a straight line? If they do, then it would be linear. But what if you don't have a graph paper big enough to go to 36? Or what if there were more than four columns in this table? What if there were like 50 columns? We don't want to have to graph 50 points just to find out one of them looks like that, and then that would mean nonlinear. Because every single one of them has to be in a perfectly straight line. So rather than looking at a picture to do it, we're going to look for some patterns. Right? And if you notice a pattern in this table, it's going to be linear. So we're on your guided notes, it says it is a linear function if we're about to get to that. First, I want you guys just to see if you notice a pattern. And then we'll go from there. Let's start with the X row. What do you notice about the numbers in the X row? Yeah? What do you mean when you say counting by threes? Like, what do you do each time to get to the next one? You add 3. Add 3. Add 3. Add 3. Again, you guys can just watch this part. There's not really a spot on your notes for it. But that's very important. We add 3 each time. Does anybody notice anything else? Yep.
For y is minus 6.
For the y's, it's minus 6. Whenever you have adding or subtracting as the pattern, that's a hint that it's going to be linear. And you might say, well, what other pattern is there besides adding and subtracting? Well, I could have a pattern like this. 2, 4, 8, 16, 32. That's different. I didn't add the same number each time. Like the first time I added 2, then I added 4. So I didn't add the same thing. Anyone see what I'm doing there each time? Yep.
Multiplying by 2.
Yeah, multiplying by 2. If your pattern includes multiplying by a number each time, that's not something that we want right now. Our pattern has to be adding or subtracting each time. Multiplying is something different. We're going to do that, but that's at the end of the year. Okay, so on the line where it says it is a linear function if, this is what you want to fill in. The first thing you do is you look at the x's. And the x's have to go up, or they could go down. So I'll just add that in. The x's could be going up, or they could be going down, but the pattern has to be addition or subtraction by the same number. So in our case, it was a +3, a +3, and a +3. Perfect. So that's good. Okay, we have to check that first. So we check the x's and see if they're going up by the same amount with addition or subtraction. Then we check the y's. And we see if they're going up by addition or subtraction the same amount each time. And in our problem, it was the same each time. It was a -6, a -6, and a -6. Now, if you made this last one a 15, now we messed it up. That's not linear now. Because it was -6, -6, now it's not a -6. So it has to be the same pattern all the way through, which means you need to check it all the way through your table. So you would never have a table of like 50 numbers. That'd be a lot to check. But 4 or 5 is pretty common. So what we'll do now is kind of the same thing we did before with pictures. I'm going to give you guys some tables. And we're going to see if the tables represent linear functions. And we're going to do this without any drawing. We're not going to draw. Okay, so does everybody have the part that's underlined and bolded? Okay. So you guys have blank tables, right? There's no numbers filled in on example 2, right? Okay. So you'll have to fill in the numbers as we go. So the question is, does the table represent a linear function? I'm not just asking you if it's linear. I'm specifically asking if it's a linear function. And that's exactly what I just explained how to do. You look for that pattern. So let's just start with the x's. I'm not even going to give you the y's. Does anybody see a pattern in the x's? Caleb?
2 is added to...
Yeah. It is a +2 each time, and that pattern never changes, so that's good. Is that enough information to tell us if it's a linear function? What do you think? Yeah, go ahead.
No.
No, we have to check the y's. So let's check those. There's your y's. Is there a pattern in the y's? It doesn't have to be +2. It could be another number. But is there a number that you add or subtract each time to get from one to the next? The same number. Sean? No. It's like to get from 2 to 9, what do you add? You add 7. So now that has to be the pattern, +7 each time, and it's not. Because to get from 9 to 20, how much do you add? Yeah? 11. So if you were to graph these points, they would not be in a straight line. They would be, it might look something like that. They're not going to line up straight. So because they don't line up straight, this is a non-linear function. Now, we did this part yesterday, but can someone remind me again? How do I know the numbers in this table are a function? Yeah?
There's no repeating numbers on the x.
Exactly. There are no repeating numbers on the x's. That part tells me it's a function. The fact that I don't add or subtract the same number each time tells me that it's non-linear. So this table tells me 2 different things, whether it's linear or non-linear, and whether it's a function or not. All right, let's look at this one. All right, C. First of all, without any more information, can you answer whether or not this table is a function? Yes, you can. All you have to know if it's a function, are there any repeats in the x's? The answer is no, there are not. So it's definitely a function. Now it's a question, is it linear or non-linear? Can we tell if it's linear or non-linear here? What do you think, Abby?
No.
Not yet. There's a pattern in the x's, though. What do you add, Abby, each time? 1. Okay, so we know it's a function. So far, we're good. We added the same number each time. Let's look at my y's. Is there a pattern in the y's this time? What do you think? Yeah? Yes, there is. You don't necessarily have to tell me the pattern. If you see the pattern, that's fine. Now we can answer the question. Is this a linear function or non-linear? Yeah?
Linear.
This is linear. This is a linear function. Okay, so we did. There might not have been an A. I think we skipped A, didn't we? On the guided notes. Oh, we did. Wait. Oh, we did A. A was okay. That was example 2. All right. So B was the next one. Okay. How about D? Is there a pattern in the x's? Yep. Yep. The pattern is a +1. Okay, so we got a pattern there. Do we have a pattern in the y's that is addition or subtraction? Okay.
Divide by 2.
The pattern in the y's is divide by 2. So is this a linear or non-linear function? Yep. It's linear? So what did we say about our pattern? What operation did it have to be? Either, yep. The pattern has to be addition or subtraction. And Finnegan, what operation did you say use?
Division.
The pattern here is division. So is this linear or non-linear? This is non-linear. This is non-linear. In fact, if you wanted to know what it looked like, it would look like something like that. It's a curve down. You don't have to know that it's a curve down. The point here is it's non-linear. But it is still a function. Still a function. There are no repeats in the x's. Okay, but it's non-linear. All right, so we've looked at determining if something is a function by looking at a picture, looking at a table. Now, the last thing we're going to do is look at a formula. Remember, for something to be a line, it has to be able to look something like y equals mx plus b. Okay, so let me show you an example. That's a line. That is exactly y equals mx plus b. Now, how about if I did this? It's not y equals mx plus b, but could I do something that makes it look like y equals mx plus b? Right?
You could add 2 so it's on the other side.
I could add 2 to put it on the other side. And when I do that, I have y equals 3x plus 2. This is actually the same one I wrote up above. So for something to be considered a line, it has to either be in the form y equals mx plus b, or it could be rearranged to be in that form. Like if I had something like this. 2y equals 8x plus 6. And I ask you, is that a linear function? Is it written in y equals mx plus b the way it is? Sean? No. Y equals mx plus b means the y is by itself. The y is not by itself. Okay, so we said here that y isn't by itself, but is there something I could do to get y by itself? What do you think, Natalie? Yeah, we could divide by 2. Divide by 2, divide by 2. So now you have y equals 4x plus 3. So the original problem was a line. Okay? It was capable of being arranged in y equals mx plus b. So there are certain things we can look for to figure out whether something is linear or not. I'm going to show you some things that can pop up in your problem that tell you right away it is not linear. If you ever see something with like a square root, okay, y equals mx plus b, that doesn't have square roots in it at all. So if you had something like y equals the square root of x plus 3, that absolutely is not line. It's not y equals mx plus b. So if you see something with a square root, not linear. If you ever come across something where you have variables in the bottom of a fraction, that is not supposed to happen in lines. That is not y equals mx plus b. Y equals 5 over x plus 6. You never have a variable in the bottom of a fraction in y equals mx plus b. That should not happen. You should never have variables that are exponents, like y equals 2 to the x, something like that. That is definitely not linear. Y equals mx plus b does not have variables up in the exponents. So these are all things that if you see them, right away you can say, nope, it's not linear. If you had a variable with an exponent other than 1, like right here, x squared plus 3. You're not supposed to have exponents when you're writing the equation of a line. It's just supposed to be y equals mx plus b. It's not supposed to be x squared. That's a different shape. X squared is actually a U shape. And we did a graph earlier where I gave you a picture of a U shape. This is what the equation of a U shape looks like. So if you see any of those things, they are not functions. So for it to be a function, you're just looking for y's, x's, and numbers. No square roots, no variables in the bottom, no exponents, nothing like that. So I'm going to give you now a few equations, and the question is going to be the same question we've been doing. Is it linear or nonlinear function? But now, we're not going to look at a table. We're not going to look at a picture. We're going to look at a formula. Okay, maybe I can keep that up while we do the examples. Let's see. Delete that. Okay, so example 3, last one. Which of the following represent linear functions? There's one other one I want to show you. Let's look at that first. Would that be a linear function? Y equals 2x plus 5. Yes, it would. Okay. That would be considered a linear function. Now, what number would I have to put right there to make this whole part disappear? Anybody think of a number you could plug in for that you can multiply by and it cancels something out? Yeah? 0. So what if I had something like this? Y equals 0 times x plus 3. What's 0 times x? Yeah?
0.
0. If your slope was a 0, what you end up with is something like that. You end up with something that doesn't have an x variable. And if that happens, that's okay. If you get y equals a number, this is a function. It's kind of a special case. I know it's not y equals mx plus b, but that would still be considered a function. There's no variables in the bottom. There's no exponents that are variables. There's no tricky stuff. I call this stuff up here tricky stuff. So let's look at A. What do you think about A? Is A a function? Linear function. It's y equals a number. Caleb?
I think it is.
Yeah, we just said that. If you end up with y equals a number, it's a special case, but that is okay. So that is a linear function. How about B? Y equals the square root of x. Is that a linear function if you were to draw it? Yep. No, it's not. We said things with square roots. So I'm not even going to write anything. I'll just cross that one out. That one is not linear. That one was. How about C? Y equals 3 to the x. Is that a linear function? No, you're not supposed to have variables in the exponent. So no, that one's not. How about D? Y equals 2 divided by x. No, you're not supposed to have variables in the bottom. How about that one? Think about what property is this right here? Like if you were to do that. Yeah?
Distributive property.
And if you did distributive property, you would have this. 6x minus 6. Is that a linear function? Yes, it is. That's y equals mx plus b, or minus b. That one's perfect. It didn't quite look like y equals mx plus b at first, but it doesn't have any of the tricky stuff that I mentioned earlier. How about that one? X squared minus y equals 0. No, you're not supposed to have exponents that are numbers. You're not supposed to have exponents. So F is out. How about G? Y equals x plus 9. Think about that one. So, yeah, that's fine. It doesn't have variables in the bottom, doesn't have exponents. This is y equals, think of m as 1 there. It's mx plus b. It's perfect. All right, so that's an idea of how you can tell. That takes a little practice to get good at. So we'll practice some more of those in the warm-up or when we go over home.
Mr. Hager,
Yes.
when you're done with that, can you run that part for me real quick?
So homework tonight. Remember, tonight is not a take-home. Tonight's a normal homework. Just go get it on Schoology, and we'll go over it tomorrow.